Okay, so this is 1996. We had started doing this in class on Friday, so we'll just continue through it. We had the equations written up. This is called a system within a system. So we have, let me just get the question. What was the question? The question was, okay, so we had a light and extensible string passing over a smooth fixed pulley with a particle of mass 7 kilos at one end, and the other end of the string passes over a pulley, and the pulley then has these two particles attached to it. So the diagram is on the Teams document, the connected particles document. So this is as far as we'd got in class. We had drawn the four moving parts of the system, and we were just about to write up the equations. So I'll just redo the equations. So we've decided that the 7 kilo is moving up. These two are connected by this piece of string T, and these two then are doing their own thing. So it's a system within a system. So the first equation, if I first of all look at this one here, this becomes, because it's moving up, T minus 7G equals 7A. The second equation is 2S minus T is equal to 0. That's the pulley. The third equation, this one is moving up relative to the pulley, so it's moving in the opposite direction to the pulley, so this is why its acceleration then is small system minus dominant. So I have to subtract the two accelerations. So this is this particle and the pulley are moving with acceleration A, and these two particles are sort of doing their own thing. So this one becomes, because it's moving up, S minus 3G is equal to M A, and the A is B minus A. And the thing to remember here is it's always the small system minus the dominant system. Small minus dominant, always. The fourth equation is this one. It's moving down, so it's 5G minus S, and because it's moving in the same direction to the pulley that it's attached to, this is going to be B plus A. So this becomes 5 into B plus A. So we've got that far, we'd written up the equations. So my job here is to find the acceleration of the three particles when the system is released from rest. So I need A and B, I've got to find A and B. So if I take equation number 1 and 2, these two, this will give me 2S minus 7G equals 7A. I'll call that one equation 5. And then if I take equations 3 and 4, these two, I can eliminate the S's, and that gives me 2G is equal to 8B plus 2A. And what I'll do there is I'll divide all the way across to get a simplified equation. I'm going to call this one number 6. Okay, now I'm going to take this equation number 5 and eliminate the S's using equation number 4. So I'm going to take equation 5 and 4. So equation 5 is 2S minus 7G equals 7A. And then I'm going to take equation 4 but double it so I can get rid of the S's. So this will become 10G minus 2S equals 10B plus 10A. And then I can get rid of those S's and I'll end up with 3G is equal to 10B plus 17A. So now I've got two equations with B and A, and I can solve them. I'll call this equation number 7. Okay, so I'm going to take 6 and 7, equation 6 and equation 7, and this will become 3G is equal to 10B plus 17A. And I'll take this equation and multiply it by minus 17, and this will become then minus 17G is equal to minus 68B minus 17A. That's an A now, not a 9. Okay, so cancelling those A's, I'll get minus 14G is equal to minus 58B, which means that B is equal to 7 over 29G. I can use this value then to get A. So I'll go back to equation 6, I'll sub in this value for B, and I'll get 4B's, which is 47 over 29G's, plus minus G. So 4B's minus G is equal to A, and that will give me 4 7s are 28 over 20, give me minus A, sorry. And that will give me minus 1 over 29g is equal to minus A. So A is 1 over 29g. So I have my two accelerations. The question says find the acceleration of the three particles. So these are my three particles, 7g, 3g and 5g. So the 7 kilo particle moves with an acceleration of A, and A is 1 over 29g meters per second squared. The 3 kilo particle moves with an acceleration of B minus A, and when I subtract B minus A, I end up with 7 over 29g minus 1 over 29g gives me 6 over 29g. And of course the 5 kilo particle is B plus A, which is 7 over 29g plus that. And that will give me 8 over 29g. And remember, each of those are meters per second squared because they're accelerations. Okay, so that was to finish off the one we started in class on Tuesday. That's what we did during Friday's class. Now, the next one I want to have a look at is it does say then, if the 3 kilo mass is replaced by a mass of m kilos, find the value of m if this particle does not move when the system is released from rest. Okay, so I've got all my equations here, and it says if the 3 kilo mass, if this fella here, this third equation, if this is replaced by a mass of m kilos. Okay, so let's see what happens to your equations. T minus 7g equals 7a stays the same. 2s minus t equals 0 stays the same. Now this one will become m minus 3g. Oh, sorry, this, not ms. Sorry, third equation, this one here. S minus mg, I'm putting in m now instead of 3, is equal to m into b minus a. And the fourth equation stays as it is. 5g minus s equals 5 into b plus a. So it says if you do this, if this 3 kilo mass is replaced by a mass of m, find this value of m if the particle does not move. So if it doesn't move, it means that b minus a must be equal to 0. So the acceleration is 0 if it doesn't move. So b and a are equal. Okay, so to find the value of m, then I'm just going to work through the equations. So I'm going to do the same thing again. I'm going to use 1 and 2. These two equations again, this is 1 and 2. This one is equation 3, and this one is equation 4. So using 1 and 2, I end up with the same thing again. 2s minus 7g equals 7a. That's equation 5. Using these two now this time, I'm going to use 3 and 4 and get rid of the s's, and this will become 5g minus mg equals m, of course the b minus a is 0, so that will be 0 here, and I'll add the 5 into b plus a, but of course b and a are equal, so this will become 5g minus mg is equal to 10b, we'll say. Okay, that gives me that equation. My now if I take, I'll call this one number 6, then if I take equation 5 and maybe equation 4 and get rid of the s's, so I'll do the same procedure again. So now I'm going to take equation 5, which is 2s minus 7g equals 7a. So that's that one. And I'm going to take equation 4 here, which will give me 5g minus s, but I'll double it so I can get rid of the s's. So I'm going to double this equation, and this will become 10g minus 2s equals 10 into b plus a. And of course b and a are equal, so that's the same as 2b. So that's going to be, it'll become 20b. So I'll get rid of my s's, and down here will give me 3g is equal to 20b plus 7a, and of course a and b are equal, so that really becomes 3g is equal to 20b plus 7b, which will be 27b. So b is equal to 3 over 27, 1/9 of g. Now, if I put this value back into equation 6, that should give me the value for m. So I'm going to use equation 6 now, and I'm going to say 5g minus mg is equal to 10 of these, 10b's, which is 10 over 9g. So 5g minus 10 ninths of g is equal to mg. And 5 minus 10 ninths will give me 35 over 9. So that means that 35 over 9g is equal to mg. So m is equal to 35 over 9. I'm sorry that's a bit squished at the end, but you get the idea. Okay, so that's question, the question that we were finishing from Tuesday. Now, the next question that I did was the question on that handout, which was about a light inextensible string. Let me just go down. I'll get the question up now, sorry for a moment. The second question on that was right. A smooth light pulley. If you look at the question, it's 2002 part B. So 2002 part B, what we had was 4 particles. Now this time we had a scale pan. You knew what the acceleration of the scale pan is. So it says a smooth light pulley is connected by a light and extensible string passing over a smooth light fixed pulley to a scale pan. So we have this scale pan over here, and we've got a particle on it. And it tells you that a particle of weight 2 newtons is sitting on the scale pan. 2 particles then of weight 3 newton and 9 newton are connected by a string attached by the pulley. So this is attached to a fixed pulley. That's a piece of string that passes over a fixed pulley, which we're not really interested in. And then we have a movable pulley down here, which we are interested in. So that's the piece of string attached to that. Now, attached to that pulley, I've got these 2 particles, but it's a different piece of string attaching them. And they are 3 newtons and 9 newtons. So I'm going to put them over here. So we've got a 3 newton and a 9 newton. Now I'm drawing your attention to something here. And this particle was 2 newtons and the scale pan was 1 newton. So the total weight of that system, that bit over there, was 3 newtons. Now I'm paying attention to the fact that I've been given the units in newtons, which are weight units. So I'm not giving them in mass this time. Normally I'm told the mass of the particles. So I had to be really careful here. They were given to me in weights. Okay, so it says that the scale pan moves up with an acceleration of g over 2. Tells you that in the question. You've got to find the acceleration of the particle of 9 newtons over here. Okay, so this is moving up. This pulley is moving down because they're attached by the same piece of string, and that's moving with an acceleration of a. Now these two particles here are attached to this pulley, so we have the red strings attached there. The 9 newton particle will move down within that system, and the red particle will move, the 3 newton will move up within that system. Now the pulley is moving down, so these two, the 9 and the pulley, are moving down. So the acceleration of the 9 newton pulley, the 9 newton particle, then will be the small system plus dominant system. So B is the small system plus the dominant system. And this one, because this is moving down and that's moving up, they're moving in opposite directions relative to each other. So this would be small minus dominant because they're moving in different directions. So just watch your signs there. So they're the 2 accelerations that we have to be careful of. And then we just begin the question and write up the equations. So the first one, over here, my scale pen, t minus 3, and it's just 3, not 3g, because remember it's newtons already, is equal to m. Now the mass of this is a weight force, so remember if 3 newtons is weight, then the mass is 3 over g, because that's already been multiplied by g to get a newton. So to go back to mass, I divide it by 3 by a. That's the acceleration. And of course I know what a is g over 2. So if I just continue this a little bit, t minus 3 equals 3 over g by G over 2. The G's will cancel and T will be equal to 3 plus 3 over 2. So T is equal to, in this case, 4.5, 9 over 2. Okay. Now, which is very nice then, because your second equation is 2s minus t is equal to 0, which means that 2s is equal to t. T is 9 over 2, which means s must be 9 over 2 over 2, 9 over 4. Now my third equation then, so that's equation number 2, this is equation number 3. The 9 Newton one is the one I'm interested in, so I'm going to look at that first. That's moving down, so it's 9 minus s, the F nats, is equal to m, which of course is 9 over g, into b plus a, and a is a half g. And when I work this out, s is 9 over 4, so 9 minus 9 over 4 equals 9 over g, into b plus a half g. I can divide all the way across by 9 there actually, and get 1 minus a quarter is equal to 1 over g into b plus a half g. And working all that out, that will give me, of course, 3/4 by g, when I multiply it across to get rid of this fella here, is b plus a half g, and that gives me b to be a quarter g. Okay, so I've got the acceleration out of the 9 Newton particle. That was the first part of the question. The second part of the question said find the normal reaction between the particle of weight 2 Newton on the scale pan. So now I'm just going over to this bit here for part 2 of the question. So you have this scale pan, and sitting on the scale pan you have this 2 Newton particle. And it says find the normal reaction between the particle and the scale pan. So of course when that particle is sitting on the scale pan, its weight is acting down and it has a reaction to the floor of the scale pan. I'll call it R, acting up. And remember, the scale pan is moving in an upward direction with an acceleration of g over 2. So what I do is I just take that as its own individual system, and using the Newton's second law, the F net's equal ma again. Because it's moving up, r minus 2 is equal to m. Now the m, remember again, is 2 over g by the a, which is g over 2. So that's r minus 2 is equal to 1, because everything will cancel out there. So r is equal to 3, and it's a force, so it's 3 newtons.